Your garden has become a maintenance trap disguised as a hobby, and the industry loves it. But here's the reality most people miss. Amish and indigenous farmers produce yields 3 times bigger using zero modern inputs. No chemicals, no constant intervention. Just polyculture design that self-regulates through plant partnerships. The difference between your exhausting routine and their hands-off approach? They designed ecosystems that work with nature instead of monocultures that demand daily warfare. This video reveals the 35 secrets modern gardening hides from you. Subscribe now, because what you're about to learn will change how you think about growing food forever. Most people think their garden problems mean they need more products, better effort, or superior genetics. Here's what might shock you. Your garden is working exactly as designed, to need you constantly. Modern monoculture gardening creates dependency by design. You plant 1 crop per bed, water shallowly daily, and the system demands endless intervention. That's not a flaw in your execution. That's the business model. Every product the garden center sells fixes a problem their other products created. Think about what you're actually doing every weekend. You're watering daily because your plants have shallow roots trained to chase surface moisture. You're weeding constantly because bare soil invites weed seeds and you've left ecological niches wide open. You're fighting pests because monocultures are buffets with no confusion, no deterrence, no predator habitat. You're buying fertilizers because you're mining nutrients out without returning organic matter. And you're repeating this cycle year after year, wondering why it never gets easier. Here's the reality. It's designed not to. Meanwhile, Amish farmers and indigenous growers observed ecosystems for centuries and designed gardens that run in the opposite direction. They don't fight nature, they work with it. And the results aren't subtle. Vegetables grow 2 to 3 times bigger. Pest pressure drops to nearly nothing. Watering happens deeply, once weekly, or relies entirely on rainfall. Soil fertility compounds annually instead of depleting. The garden improves with age instead of demanding more inputs. Here's what most people miss completely. The problem isn't your soil quality. It's not your climate. It's not your effort level. The problem is structural. You're gardening backwards. Modern gardens are monocultures, which are inherently unstable systems, requiring constant external inputs to survive. You're trying to force a high-maintenance design to work through willpower and weekend labor. But think about it. When's the last time you saw a forest that needed weeding? Nature doesn't do monocultures. Forests don't. Prairies don't. Healthy ecosystems are polycultures where every plant serves multiple functions and supports surrounding plants. Let's talk about what that means practically. When you plant monocultures, you create systems with single points of failure. One pest species devastates the entire bed. One nutrient deficiency affects everything. One dry spell kills shallow-rooted plants. You're playing constant defense, reacting to problems your design created. Indigenous farmers flipped this entirely. They designed polycultures where plants protect each other, feed each other, create resilience through diversity. Here's a simple example demonstrating the difference. You plant a bed of tomatoes. Pests zero in on the scent signature immediately because there's nothing confusing them. The plants compete for identical nutrients at identical soil depths. You're watering daily, fertilizing weekly, spraying for pests. That's monoculture in action. Now watch what happens when you design relationships instead. You plant tomatoes with basil at the base. Basil's volatile oils confuse pest insects hunting tomato scent. Basil stays low, tomatoes grow tall, so they're not competing for light. Add marigolds at the border. Marigolds repel aphids and attract predatory insects that devour tomato hornworms. Suddenly, 3 plants work as a team. Tomatoes get pest protection without spraying. Basil gets shade and structural support. Marigolds get pollinator traffic. That's functional design eliminating problems before they start. Here's another combination solving multiple problems simultaneously. Carrots and onions in alternating rows. Carrot flies hunt by scent. Onion flies hunt by scent. When you interplant them, each plant's aroma masks the others, and both pest species get confused and move on. You've eliminated 2 pest problems through spatial arrangement, not products. No spraying required, no daily monitoring, just observation translated into design. Here's one more demonstrating the nitrogen economy most people completely ignore. Peas or beans planted near heavy feeders like corn or squash. Legumes have root nodules containing bacteria that convert atmospheric nitrogen into plant-available forms. When legume roots die back or you cut plants at soil level, that nitrogen stays in the soil feeding nearby plants. You're fertilizing through biology instead of bags. This happens automatically in the background while you're living your actual life. This is where it gets interesting. These aren't isolated tricks, they're stackable design principles you can scale infinitely. Every plant in a polyculture serves multiple functions. Nitrogen fixers feed neighbors. Deep-rooted plants mine subsoil minerals and bring them up. Living mulches shade soil and suppress weeds. Tall plants provide trellises for climbers. Aromatic plants confuse pests. Flowering plants attract beneficials. You're not just reducing problems, you're building systems where plants solve each other's problems automatically. That's the fundamental shift modern gardening refuses to teach you. Conventional approaches treat plants as individuals competing for resources. Indigenous systems treat plants as teammates with complementary skills. One approach requires constant management and weekend sacrifice. The other becomes more stable over time. But here's what makes this accessible instead of theoretical. You don't need acreage. You don't need perfect conditions. You need to understand which plants work together and why. Start with guilds, small plant communities designed around relationships. A 3-plant guild and a 4x4 raised bed demonstrates these principles within 6 weeks. You'll see pest confusion working in real time. You'll see nutrient sharing. You'll see structural support. Let's talk about how indigenous farmers actually structured their growing systems. The most famous example is the Three Sisters, and this isn't cute historical trivia. It's a masterclass in functional ecology that eliminates most problems modern gardening creates. Here's how it works and why the garden industry doesn't want you understanding this. The Three Sisters are corn, beans, and squash planted together. But the magic is what each plant does for the others. Corn grows tall and provides living trellis structure. Beans climb the corn stalks instead of needing stakes you'd buy. While climbing, bean roots host nitrogen-fixing bacteria that convert atmospheric nitrogen into fertilizer feeding the corn. Squash grows low and spreads wide across ground. Those massive leaves act as living mulch, shading soil to retain moisture, suppress weeds, keep the root zone cool. The squash leaves are also covered in tiny spines deterring raccoons and other animals from entering the bed. 3 plants, 6 functions, 0 external inputs required. Think about what's happening here. You're not buying fertilizer because beans produce it biologically. You're not buying mulch because squash creates it structurally. You're not buying trellises because corn provides them. You're not weeding because the squash canopy blocks light and prevents seed germination. You're not fighting pests because diversity confuses them and squash spines deter larger animals. All of this happens automatically once you arrange plants correctly. Now compare that to monoculture. You plant corn in rows. It needs nitrogen, so you buy fertilizer. It needs wind support, so you stake it. Weeds grow between stalks, so you're pulling them weekly. Pests find corn easily because there's nothing confusing the scent trail. You're managing 6 separate problems the Three Sisters design eliminates through observation and spatial relationships. Here's what most people miss. This scales infinitely. You can plant Three Sisters in a 5-gallon bucket on a balcony. You can plant it in a 4x4 raised bed. You can plant it across half an acre. The relationships work at any scale because they're based on plant function, not space requirements. 1 corn stalk supports 1 bean vine. 1 squash plant shades roughly 6 square feet. The ratios stay consistent whether you're planting 3 plants or 300. Let me give you more companion combinations solving specific problems the garden center pretends need products. Tomatoes with basil and marigolds. We covered pest confusion earlier, but here's the nutrient angle most people ignore. Basil has shallow roots. Tomatoes have deep roots. They're not competing for water or nutrients because they're mining different soil layers. The marigolds produce root exudates that repel nematodes, microscopic worms attacking tomato roots. 3 plants, 3 layers of problem solving, 0 chemical inputs. Cucumbers with nasturtiums and radishes. Nasturtiums are trap crops. Aphids prefer nasturtium leaves over cucumber leaves, so they congregate on nasturtiums where you can ignore them or remove the whole plant. Radishes break up compacted soil with taproots, creating channels for water and air reaching cucumber roots. When radishes finish their cycle, you pull them, eat them, leave holes in soil that improve drainage. Nasturtium flowers attract pollinators that also pollinate cucumber flowers. Everything benefits. Lettuce with chives and calendula. Chives repel aphids through scent. Calendula attracts hoverflies whose larvae eat aphids. Lettuce grows fast and shallow. Chives grow slow and deep. No competition. Calendula flowers also indicate soil moisture levels. When they start wilting, everything needs water. You've got pest management and an irrigation indicator built into the design instead of buying moisture meters. Cabbage with dill and thyme. Dill attracts parasitic wasps that lay eggs in cabbage worms. The wasp larvae eat worms from inside. Thyme is low-growing ground cover, preventing weed germination around cabbage. It also repels cabbage moths through scent. You're controlling 2 major cabbage pests without spraying and suppressing weeds through living mulch instead of hand-pulling every weekend. Pole beans with sunflowers and winter squash. Sunflowers grow faster and taller than corn, providing earlier trellis structure. Beans fix nitrogen for sunflowers. Winter squash has even larger leaves than summer squash, creating aggressive weed suppression. Sunflower seeds feed you or wildlife. Bean nitrogen feeds soil. Squash provides long storage food. 3 plants producing multiple yields from one bed. Notice the pattern here. Every combination eliminates at least 2 problems monocultures create. Pest control through confusion or predator attraction. Nutrient provision through biological fixation or root mining at different depths. Structural support through height differences. Weed suppression through ground shading. Water retention through living mulch. These aren't random pairings someone thought looked pretty. They're functional teams designed through observation. And here's where the yield comparison becomes undeniable. A monoculture tomato bed might produce 20 pounds of tomatoes if you manage it intensively with constant inputs. A polyculture bed with tomatoes, basil, and marigolds produces 20 pounds of tomatoes plus basil harvests plus reduced pest damage, which means better fruit quality and less loss. The bed does more work in identical space with less input from you. That's the 3 times bigger claim. You're not just growing bigger individual plants, you're multiplying outputs per square foot through stacking functions. Indigenous farmers observed these relationships over centuries. They watched what grew together in wild ecosystems and replicated those patterns in gardens. When you walk through a forest, you never see monocultures. You see vertical layers. Tall trees, understory shrubs, ground covers, root vegetables, vines climbing up through everything. Every plant occupies a different niche. That's what you're replicating at garden scale. But these relationships only work above ground. Now let's talk about what's happening below, because soil is where the real magic compounds over time. Most people treat soil like dirt, something inert holding plants upright. Here's the reality the garden center won't tell you. Soil is a living ecosystem, and how you manage it determines whether your garden gets easier or harder every year. Indigenous systems build soil instead of depleting it. They use a technique called chop and drop, which sounds absurdly simple but changes everything. When plant material dies back or you harvest, you cut it at ground level and leave it right there on the soil surface. Those leaves, stems, and stalks become mulch. Then they decompose in place. Think about how you water your garden right now. You're probably out there every evening with a hose or sprinkler, hitting the surface for 10 minutes, watching it soak in, moving on. That's standard advice everywhere. Daily, shallow watering. And here's what most people miss. You're creating exactly the problem you're trying to solve. Shallow watering trains roots to stay near the surface chasing moisture. Those shallow roots can't access deep soil moisture reserves, can't anchor against wind, can't mine nutrients from lower layers. You've created dependency through your watering method, and the garden center loves selling you solutions to the crisis your technique caused. Indigenous systems flip this completely. They water deeply and infrequently. One heavy watering session weekly penetrates 12 to 18 inches down. Roots follow that moisture deep into the soil profile. Once roots establish at depth, they access moisture reserves even during dry spells. The plant becomes drought resilient not through constant intervention, but through root architecture you designed. Deep roots also mine minerals and nutrients from subsoil layers shallow-rooted plants never reach. You're building resilience through watering strategy instead of creating dependency you have to manage daily. But here's where living mulch becomes critical, and this is where conventional gardening advice completely fails you. When you have bare soil, evaporation pulls moisture straight up and out. You lose water to atmosphere before plants use it. Living mulch changes the physics. Those squash leaves, those low-growing ground covers shade the soil surface and reduce evaporation by 60 to 70%. The air under the canopy stays humid. The soil stays cool. Moisture retention happens passively without any action from you. You're not fighting evaporation with daily watering. You're designing a microclimate that prevents evaporation from happening. And the mulch layer does something else the industry won't mention. It creates habitat for soil organisms. Beetles, springtails, worms live in the cool, moist zone under mulch. Those organisms break down organic matter, aerate soil, create nutrient cycles. You're not adding these inputs manually. You're creating conditions where biology does the work automatically, while you're doing literally anything else with your weekends. Now let's talk about seed saving, because this is where the system becomes truly self-perpetuating, and you stop paying seed companies forever. Most people buy seeds every year. They're paying for genetics someone else selected in a completely different climate, with different soil and different pests. Those seeds might perform adequately, but they're not adapted to your specific conditions. Here's the reality. Indigenous farmers took a different approach. They saved seeds from the strongest, most productive plants every season. Over time, those seeds adapted to local conditions. Pest resistance increased. Drought tolerance improved. Vigor compounded. You're not buying generic genetics. You're developing site-specific cultivars through observation and selection. Here's how it works practically. At season's end, you identify your best-performing plants. The tomato that produced the most fruit. The bean that resisted pests. The squash that handled heat stress. You let those plants fully mature and save their seeds. Next season, you plant those saved seeds. You repeat the selection process. By year 3, you're growing plants specifically adapted to your yard's microclimate, your soil composition, your local pest pressure. And you're doing this for free. 0 seed costs after year 1. 0 dependency on external genetics or corporate seed catalogs. Think about what's happening over a 5-year timeline, because this is where conventional gardening's lies become most obvious. Year 1, you're setting up guilds, establishing deep-rooted plants, building your first mulch layer, saving your first seeds. You're doing moderate work, learning the system, observing what thrives. Year 2, your soil biology is waking up. Chop and drop mulch from year 1 has decomposed into humus. Nitrogen-fixing plants have fed soil. Your saved seeds are slightly more adapted. Pest pressure drops because beneficial insects are establishing. You're watering less because roots are deeper and mulch is retaining moisture. Year 3, the system is starting to run itself. Soil fertility builds annually. Your saved seeds are noticeably more vigorous. Perennial companions are fully established. You're spending maybe 30 minutes weekly on observation and harvesting instead of hours on maintenance. Year 4, you're barely intervening. The polycultures self-regulate. Pests and beneficials are balanced. Soil practically grows itself. Year 5, the garden is a self-perpetuating ecosystem. You're harvesting, saving seeds, occasionally planting. Everything else happens without you. That progression is the exact opposite of what happens in conventional gardens. Conventional gardens start hard and stay hard. Year 5 looks identical to year 1. You're still watering daily, still fighting identical pests, still buying identical inputs. Indigenous systems start with moderate effort and become nearly effortless. The work front-loads into design and observation. The payoff compounds over time instead of staying flat forever. Now here's where people panic about modern constraints. What if you don't have land? What if you're renting with a balcony? What if your HOA bans vegetables? Here's what most people miss. These systems scale down and disguise easily. A 5-gallon bucket holds one Three Sisters Guild. 3 buckets give you meaningful yields. A 4x4 raised bed supports a full polyculture. You can grow tomatoes with basil and marigolds in containers on a balcony and get all the pest confusion benefits. The relationships work at any scale because they're based on function, not space. For HOA situations, you can disguise productive guilds as ornamental landscaping. Tomatoes look like flowering plants. Beans climbing decorative trellises look intentional. Squash with large leaves looks like ground cover. Marigolds and nasturtiums are flowers. Nobody's flagging your landscaping when it looks attractive and well-maintained. You're growing food that looks like designed landscape because it is designed landscape. So here's how you actually implement this starting next weekend. Pick one guild. 3 sisters if you have ground space. Tomato, basil, marigold if you're working with containers. Plant them according to their relationships. Corn or tomato as tall structure. Beans at the base of structure. Squash or ground cover around perimeter. Water deeply once to establish. Then wait until the top 2 inches of soil dry before watering again. Let the system develop for 8 weeks. Observe what happens. Watch beans climb. Watch squash shade. Watch pest pressure stay low compared to monoculture beds nearby. After 8 weeks, you'll understand these principles experientially instead of theoretically. You'll see companion planting working. You'll see living mulch retaining moisture. You'll see how much less work the polyculture requires. Then you expand. Add another guild. Try different combinations. Save seeds from your strongest plants. Build your soil with chop and drop. Keep observing. Keep adapting. The core principles don't change. Design relationships between plants instead of planting monocultures. Build soil in place through organic matter instead of buying amendments. Observe what works and adapt instead of following rigid schedules the industry sells you. Those 3 principles eliminate most problems modern gardening creates. You're not fighting nature. You're working with patterns nature already demonstrated for millennia. Here's what you're not doing anymore. You're not watering daily because deep roots and living mulch retain moisture passively. You're not weeding constantly because ground covers block light and suppress germination. You're not spraying pests because companion planting confuses them and beneficials eat them. You're not buying fertilizer because nitrogen fixers and decomposition provide nutrients. You're not buying seeds after year 1 because you're saving adapted genetics. You're not spending weekends on maintenance because the system self-regulates. Calculate what that means practically. Conventional gardening requires roughly 2 hours weekly during growing season. That's 100 hours yearly fighting problems your design created. Indigenous design requires maybe 20 hours setup in year 1, then drops to 20 hours yearly for observation and harvesting by year 3. You're getting 80 hours back annually. That's 2 full work weeks. That's 10 weekends. And you're getting better yields with 0 ongoing costs. That's it. Stop fighting. Stop buying solutions to problems monoculture design creates. Design a self-regulating ecosystem once, observe how it develops, adapt based on what you see. Your garden becomes easier every year instead of harder. Your soil improves instead of depleting. Your plants adapt to your specific conditions instead of struggling with generic genetics. And you get your weekends back to actually enjoy results instead of endlessly maintaining the system. This isn't nostalgia for old methods. It's functional ecology applied to modern spaces. Amish farmers grow vegetables 3 times bigger without modern tools because they designed with observation and relationships instead of intervention in products. You can do the same thing in raised beds, containers, or suburban yards. The principles scale. The relationships work. The system runs itself. Your future self will thank you for learning to work with nature